After the tester has diagnosed the readings, transfer the results from the 810 to the viewer software on your PC for review. Inside the software, we can quickly review all 6 axes of data at one time, set up multiple machines, view diagnoses, set up preferences, and print reports. Here we see 2 different screen captures of the viewer software. On the top, we show how we can set up multiple machines using your PC. We use the same wizard found inside the Fluke 810 vibration tester as we do in the viewer software. But with the viewer software, you can now use your mouse and keyboard and monitor of your PC. When you're done, transfer the machine settings to the vibration tester. At the bottom, we can see preferences. We can change settings, set dates for filters, and update the software with new releases from the Fluke website. Here we see another 2 screen captures. The one on the top shows how to view diagnoses. These diagnoses were made on the vibration tester. Simply select the machine from the tree on the left, select the test date. We'll see a list of the faults, severity, severity score, and recommendation. You can print the reports and export severity levels to Excel. At the bottom, you can see how we can view data, all 6 axes, for a quick review. The data is arranged in a way to optimize fast review to ensure the data is valid. To view the data, select the way you want to see the data. The default will optimize data screening for a quick review. The 2 graphs on the top show how to change the frequency units. The 2 graphs on the bottom show how you can change the amplitude units. When the machine was first set up, the optional information is left blank because we didn't know the number of elements on the pump, fan, compressor, or blower. You can sometimes find this information in the data and then go back to update the machine setup. This will update the diagnostic engine and help to increase the accuracy of your reports. So here we can see if we quickly review the data on the machine, missing information is obvious. You can see the differences by quickly looking at the data on the motor on the top and the data from the compressor at the bottom. Notice we'll see some patterns or a series of harmonics in the graph for the driven component, but not on the motor. Pump, in this example, we see a peak at 4x and a peak at 8x in the low range, but only on the compressor, not on the motor. If this data was from a screw compressor, then we have 4 screw threads. If the data was from a fan, then there are 4 fan blades. If the data is from a pump, then there are 4 impeller vanes.